So what I see today is that the talk is like targeted for beginners, absolute beginners without prior knowledge. So I'm gonna probably go pretty fast through that because I think everybody here familiar except Peter with the subject. So.
Send them
But I also want to, for people who was not here last time, I want to do a fast recap what was on the last session. And so if you're interested in particular thing about that, you can talk to me after that. So in the last lecture, we talked about introduction to command line and computing. I told a little bit of my story, how I went from the artist to sort of, tech person and knowing a lot about computers.
Look at that hair.
Yeah, look at the hair. Me playing Counter-Strike on the right. So I think it's my first computer at 15 years old, so it's relatively late. So I also went through an introduction how the computer works. We're going to recap right now of the last session. And so I started with a transistor, explain what transistor does and what like electronically, and that you can combine transistors. I recommended this book, which is pretty awesome, very short book. It goes and start explaining from fundamental principle. You take a transistor, how you create a logic gate from it. From a logic gate, you can build more complex mathematical operation, and then you can build memory cells, and you can build entire computer just from a single pretty much elements. And I provided this diagram, which was drawn by me, kind of very contrived version of, which I think gets the point across of fundamental of how a computer works, and that there is a logical mathematical unit that you can address and call by its addresses, and there are little memories as well and registers. And then I show how this is actually translated to machine code, where you can call an address for a multiplication, and you provide two values, and the CPU does this multiplication, but it does it on the hardware level. So it's not the software; it's like actual logic gates connected together on the CPU to actually do that operation. And then how people went from this machine code at the beginning, they realized it sucks to read, and they created like an assembly language, but then they needed an assembler that which can convert from that human readable to a machine code. And then, So, and of course, people didn't stop there. They start building more complex abstract languages, and this is a snippet of Python, of like a more modern language that reads more like English, but require, of course, a lot more conversion, I would say, for computer to read. Yeah, and the level of abstraction is high. Sometimes abstraction, I feel like for beginners, it's like, I still struggle. It's like, what is abstraction? Yeah.
Layers, I guess.
And after that, we actually did pretty good. I did a live demo session. I'll show you. So this is the points that we went through. I show a basic of, and so to get the point across, so I went through like how computer program is created and what computer program is, and then that how the terminal is the way basically to run any computer program. So any binary file you have on your system, and that's what terminal interaction of user with computer like is built off. It's like you just call different programs, you sometimes connect these programs together, and so on. So, and this is the command we looked through, some very basic command line utilities. So today I want to briefly talk about the computer networking in internet, kind of an extension of that, because the network is ubiquitous nowadays, and we all use that and connect it, but only like few understand what the fuck is going on in there. So it's all started in the 1970s. For some reason I don't have this date. With the creation of ARPANET. It was the first computer network that that used what's called packet and routing, and it was. Sorry, this is an overview section. So we're going to talk about ARPANET, how routing works, submarine cables, and a little bit of network protocols. So ARPANET. So this is the first map of ARPANET that was basically connecting major university of United States. It was imagine the computer was large, very expensive. Only a big institution can have them, but they already have this idea that they needed to create a network that is more resilient than an existing telephone network, and that was sort of the major property. There's a lot of support by U.S. Defense Agency, and they at some point they even took sort of care of that project until it become kind of more into the hands of people at university and researchers start living on its own. So important word here is resiliency. So the network primary goal was to create something that is more resilient than the telephone network at the time. And the telephone network of the time worked the following way. It was like you dial your target, and the connection goes straight to the target. And if something happened on that way along the line, your connection is interrupted, and there's no way for you to call. And this is a operator manual telephone switch board in New York. And what those people are doing there, they wiring physical things on the board to connect people from like different destinations depending where a signal goes. But those people act basically as the manual routers. So they're routing a signal, and you call this lady. I don't know how it actually like worked in principle, but this is crazy shit. Look at those supervisors. There's three. Maybe there's another one like over there as well, like watching the supervisor supervising.
There's actually a telephone switch museum in Seattle that they keep all of them operational. You would like it.
Operational?
You can go on Sundays. They give tours.
That's cool.
Yeah, it's all operational. So you can call, and then you can hear. You can like dial on the like a phone and hear the switches like triggering.
Crazy.
Yeah.
So they had this problem that it was very unreliable, and I think it was like what 50s, right, 60s. People were pretty much thinking about nuclear war. If the missiles strike, they take some like telephone data center, the whole country, like East Coast can connect to West Coast because it's like everything goes direct, and there's no real good way to reroute it efficiently. So then everything like changed with invention of the computer routers, and this is how the modern router will look like, which basically replace all these ladies. So each of this port can be thought as individual like lady switch in the thing where the signal goes, so this machine can decide how to route the signal. And what's really routing is about. So the idea when those people on first ARPANET created this idea of packets and routing, that was very fundamental idea how internet works. Instead of sending a direct electrical signal to the destination, they decided to create an abstraction layer where your network consists of multiple connections to your destination. In this case, there are two wires, right? And the packets get sent along a particular route. But on each point of this route, you have what's called a router. And the router is a smart machine like this lady who can decide, basically ask one simple fundamental question. Does the address of this piece of data that I'm receiving belong to me? If the answer is no, it's going to send it to the next router. That's pretty much how much of the world this thing understands. So it has a table called the routing table on the thing, and it's only know its sort of direct neighbors. So it sends the packet its way. The next way, and this router does the same thing. Does this IP address belongs to me? Said no, so it sends it to the next router until it's reached the destination, and they say it belongs to me. Yes, it belongs to me, and that piece of data is processed. So
that's
that
kind of like Google Maps, like it's following like a route, right?
in which way?
In the sense that there's like it can't just jump between the two, right? Like it has to.
Right. But what's important about this to understand, if you have a network now and the thing goes to a switch, and let's say one of the destination goes down, well, sure, you have just another destination. The system sort of self-healing, and no matter what, the piece of information is going to always find its destination, unless you have like a one path connecting the destination. If you have no path, of course.
Well, then there's like duplication in the messages, right?
There's all kinds of details to this, like there's all kinds of algorithm involved.
yeah.
This is like super contrived
Sure,
sort of way to describe that. Yeah. And I want to mention about the, not the idea, but about the submarine communication cable. There's a often misconception when I ask people who usually know nothing about the subject. I was like, do you know how data gets transmitted over internet? And people say it's like, oh, it's over a satellite. So in reality is that over like the last, I think 70 years, they started, first cable was laid in, it's actually 100 years. I think first cable was, telegraph cable was laid in like in early 19th century. So between, I think New York and London. But, and till today, this is the most efficient and the most bandwidth capable way of transmitting data. So if you go to this website is super cool because you can see all this stuff interactively. Check it out. This is, for me, when I sort of like learn about all the submarine cables, that blew my mind. Because like imagine the distance between all this location, you have all these cables, and basically humans just like made a web under submarine all this, like, you know, oceans and like encompassing all these continents. Is like insane. And just kind of imagine that every time you like, you know, press a Google search, like a piece of data getting like, you know, encapsulated into this packet and sent over this crazy wire underneath the ocean, and you know, and that thing going to reply to you back, and it just happened like every day. Amazing. So all of that, one of the most, when people realized they sort of can communicate this way, was necessary to create what's a standard, which also can be thought called a protocol. Because if you're sending a piece of data and then you're expecting certain things to happen on the other end, you need some sort of the other side to understand how to process this piece of data. And the core protocol that people designed at ARPANET days was TCP, which stands for Transmission Control Protocol. And this is the most fundamental protocol that basically governs modern internet. There are other protocols, but this one is the most important one. And the most important property of this protocol that is reliable. And the way, is it here? No. So the reliability of this protocol is achieved through basically a very simple principle. The packet gets sent along the network, and as a sender, I expect the receiver send me acknowledgement back. So, and if I don't receive the acknowledgement, I'm going to resend this packet again until I get the acknowledgement. It's basically saying, hey, did you get this message? I even heard this similar idea implemented in like social networks where for certain operation where like, oh, you need to complete this task. Like, let's say you need to send a mail, and the person goes send the mail, he come back, and then like you didn't ask him to send, like you don't know that mail been sent, or maybe something happened. And there's like social rules that people establish in the community saying, you need to tell me every time the mail is sent, you need to confirm, to go back to the person and say, I sent the mail. And he's like, all right. So it's kind of like this idea of acknowledgement that is fundamental to this protocol. And what's interesting, sort of kind of scale it very fast to the idea like this protocol control all these details about how packet is transmitted, very low level, the acknowledgement, is it data lost, if not, you know, if it is, it's you retransmit the data. But we want to like build something useful for people, and people early on came up with another protocol which works on top of that. So like all network stack can be thought about in terms of a layer. So everything just layer in the computer in general. You start with bits and then you create higher abstraction. And so in this case, people came up with the hypertext transfer protocol. And this is, you can see right here in the address bar. So we're using HTTPS, which is just a secure version of this protocol. So, and this is just a basic text protocol that works on top of TCP that we just discussed. It's basically a plain text protocol that used to fetch markup data of web pages. And example, if you send, if you like intercept this packets over the wire, you'll see something like this. And we can actually go and try that on the terminal. Oh, wide terminal. How bad? So I'm trying. The most sort of simple way that you can send what's called a web request is a program called netcat. Short version stands for NC. So if I just run it, it just gives me a sort of instruction how to use it. So if I type netcat, I forgot the syntax. Let's see. Well, this is a page I make. This is the same information for the HackNight. So let's try that. This is resolve DNS. 7. How to search.
You probably have to do host name and port.
Ah, I don't think I can do this path right here. Yeah.
Port name. It's just maybe space.
The port after us with the space.
Mm-hmm.
Okay, cool. So if you run this command, so what it does, it connects over a TCP to my server. This is my personal actual physical machine in the cloud with a domain that I made, CoderCAD and so it connects to the port 80. And the port 80 is there's a concept of port in Unix. So a port basically is a it's for for a machine to receive a connection, because there can be more than one connection. So, and this is the idea that you can have several connections. They will use different ports, and you can have different streams of data. So, port 80 usually used for any web traffic. When you type a URL in your browser, it automatically appends that port. You just don't see it. So it happens transparently. Sometimes you've seen Vincent ask you to type like 5001 to accessing our network attached storage. That's exactly what's happening. So it's just a different service running on that machine. So in this case, if I type this, it seems like it's hanging, but it's not hanging. It's actually established TCP connection. It's waiting for other input. And so what I can do, what we can try to do at least, we can try to copy this string, which we're going to modify a little bit. Or maybe not. Oh, shit. It doesn't support like a cursor. So this is what the HTTP protocol, because I'm running a web server, the web server expects to just this text. So if I send that and press space, here you go. So this is awesome. So it was very simple. So I just send the string to my web server, and it replied with the following. So there's a bunch of metadata that it said HTTP status okay. That means it's just the metadata about the reply, and this is all the part of the specification of HTTP protocol. And then it replied with this, which is a markup language for my page, which is not. We said welcome to Nginx, so it's not actually my site. So anyway, but you get the idea. So if I try to go CoderCAD and maybe I mistype something. Yeah, so I said this Nginx stuff. Not sure which page I access when is the welcome change next. Yeah, cool. So this is all I have. Any additional questions?
Is Netcat a built-in package, or is that a third-party thing?
It depends on which system are you. I think it built in into some Linux.
You can, if you check the manual, like man NC, we can see probably where it belongs to. I don't know if it's core utils or what.
You don't use
sorry.
Telnet in a similar way.
If you go to the very bottom, it normally tells you.
So this is what it say: arbitrary TCP and UDP connection and listen.
So if you go to the end, it's like normally says to where it belongs.
Says macOS 51.
I
So space.
I feel like I installed this brew.
Do which space NC? It looks like it's a system.
Well, we can do a less on that. Oh, sorry.
User bin.
Yeah, it looks pretty native to me. But you can try, if anybody has Mac, you can try to run it. NC is awesome, so you can connect to some other computer. We can actually try it now. Does anybody have NC here?
I do.
We're going to do a listen on the port. NC listen.
Dash out.
Does it there's a chance that it's not really full.
Locally?
I think we have to say.
POSIX basic.
This should work, right? Can you try?
What's your IP address?
Yours said Mac OS, right? So it was like a different implementation. Maybe. It was like
Where this one?
Yeah, 10 times 1. Is it 187 or 107?
107.
Port 8000. What was the port you were saying?
8,000.
There you go.
Great. You wanna try? Who wanna try?
Control D.
You can send files this way, which is awesome.
Control Command D.
Oh my god.
Wait, how do I get to it again?
Through the router. This is local.
So this is my IP.
Type in NC space and then
Minus 1,000.
no 10.10.13.107 space 8000. Press enter and then just type something in and press enter.
Someone already typed something. ISDF. Who's that?
Yeah, see.
It's a dick. That's Will.
Yeah, so for some reason you can see it.
Well, can someone send me a file?
Weird.
Oh yeah. Do I pipe into it?
Yeah. What is it gonna save though? Do I need to pipe it too?
Yeah, okay. Yeah, let's see.
So what I'm seeing is that it's normally packaged under the Libre SSL collection of packages.
Hi.
OpenBSD has its own, so before that's the
I'm
Mac
sorry,
OS.
I'm late.
Wait, can you restart it? Because I think it isn't in a mode where every connection takes over the thing.
Yeah.
Yeah.
Oh. What is that?
What? What is that?
Who sent that?
That's
Who
me.
sent that?
That's me.
That's you.
Yeah. There's a command called banner that lets you make ASCII messages.
Really?
Yeah.
I didn't know about this command.
I still don't get how you connect.
Oh yeah. So, well, the problem is wait, you need to run an NC with an extra flag for force. Something like that. what's been happening is the first person to connect gets the connection and doesn't listen anymore.
Yeah, I
It's
get
not
it.
acting as a server.
It's not.
I haven't done this, right? Can you?
Anybody else? Follow me. What's going on?
Send something.
You gotta send me your name.
So, hello, call me later.
Yeah, so you just have to. So now you can run that command again and it should work.
You know my remember my IP?
Yeah, just run that. And then click on like follow.
You want to crinkle it fast and get it over with?
Wait, started it one time? See. If this will work. I don't think this will work, but.
And how do you find that address?
You type if config. You on Mac?
It's not the same now.
Correct. But this is your address. You're connecting to his address.
Oh, okay.
Yeah.
Did you get something?
You
You're
know,
not
run that
listening.
NC command
No, I'm not
one
listening,
time.
sir.
There you
Holy moly!
You got an actual fireplace?
Jesus Christ! I've never seen something like this before.
This is printing?
Yeah, it's text. There's a library called libkaka, and it allows you can like, you can. Or it used to be called AAlib, but that's the black and white one, and then Kaka added the colors.
So
You can actually run MPlayer, like a video player, with output to this.
it's crazy.
Um,
So what's happening for those who don't understand is that he's sending me characters over network at certain interval.
Try
And-
scrolling up.
no, it uses it's an encursive. So
Yeah.
the terminal has these
Holy
control
crap.
sequences that say like clear screen or relocate cursor. So it's like
Yeah.
different levels
Start
of
it.
terminal.
What?
Someone sent me a binary file, so
Send you a
this.
JPEG.
So I guess I need to wait. I need to pipe it though. So let's try again. So Will trying to send me a
No, you
file.
gotta pipe it. Or, I don't know if you can stream.
I think I can.
Maybe not JPEG.
What do you mean you cannot stream? Yeah, it's can stream.
So Will tried to send me a file over just a raw TCP connection that I'm going to. This is a pipe character. I'm going to basically pipe into a file on my system. You did already?
Yeah.
New file space.
Huh.
Before you do that, just to
Yeah.
make sure.
Just to make sure.
Yeah. There you go. It's
Yeah.
a JPEG.
Just in case it's a
Wait, it's a nude.
Eh,
That's a video
It's a
photo.
Trojan.
you in sauna?
Whoa.
So this is a pretty cool way to actually exchange files. Sometimes you need to send some like a large text or a large file. You just like
So
do the NC, and then it's a pretty great way on the local network. Sometimes kind of handy.
Wait,
Do you have like
can you recap for me? You're sending a file through the local network,
I just sent him a name.
NC netcat.
Yeah. The netcat is a program that allows you to open a connection to a raw TCP connection to run any address.
So that 8,000 is like is the
No, 8,000 is just a random port that I'm providing that people can use.
and they
Al
can
means
also-
listen.
Listen. Okay, so listen on 8. Okay.
Yeah, listen. Listen for TCP traffic on the port 8,000. That's what it means.
Yeah, but so and then pipe it to a JPEG named test. And someone sent you that?
And then
Yeah, will.
And but is it like there's
So
a
go to
queue?
the
Like you get
directory
the first thing that's waiting in the queue, send it to this
Yeah, in this case, it's just whoever first connected, then it just closed the connection.
while you're listening. Okay, you open the listening,
Mm-hmm.
and then he sends something. It goes there, and then
now
when you
do
close it,
cat.
does it delete test JPEG?
No, the JPEG is permanently
It's
saved
stored
on my
in
disk.
Your current directory.
Yeah, so if I do ls,
Image, name.
list directory, I'm in this. Actually in the web directory, and there's.
But
Vertical bar
if
pipe.
okay, so if you had it open, and Will sent you something,
Yeah,
and
Okay.
then Seba sent something after that, would it
You
clobber
could
the
do that.
test?
I just typed
Would it
it.
clobber?
Only one person can connect at the time. in this particular situation.
Does it boot someone, or if Seba tried connecting while Will was connected,
That wouldn't be,
then
yeah.
it
This,
wouldn't go
this
through?
only accepts
10
one
on 10
connection
on
and that's it.
And so then the second person can't get through, or it goes to the
Correct.
person?
When you're running a normal server, you would
Open
as
it.
soon as you receive a new connection.
Oh, wow,
you
Banner
take it
is
off to
cool.
A different process, and then you would keep listening, and then open your
Check it out.
That's
Yeah.
so cool.
yeah.
How'd you do that?
Kif, try listening again.
Yeah, Banner.
Hold on.
Nice.
So that's the
Wow.
call. You have to ask them to listen.
Kif, would you listen?
Would you listen? Would you listen, please?
Would you just listen?
Did you
Kif,
send
can you
it?
just listen?
I'm listening on
Try
port
it.
8000 now.
Kif, just listen. Hey, listen.
Oh, come on. Already dick pics?
It's foot pics for sure.
Okay, you gotta do it one more
Foot pics.
time.
It's foot porn for sure.
No, it's wood porn.
I'm going
Hold
to
on,
do
you gotta do it
file.
one more time.
So a file command basically tells you what file type it is. I need. So this is a GIF animation. It's definitely a dick.
Let's open it.
I know the thing the internet was made for. Cats.
Yes.
Let's go. I'll go to my Mars space. So creepy. Is it mummified? Sounds real cat, huh?
It is real.
All right.
Say it
That,
one more time.
that was fun.
There's a cat trying to install it on Windows.
Wait, 1 second.
Install what?
Netcat.
Oh, it doesn't come. Netcat's thing.
You should be able to download the pre-built binary for Windows,
Yeah.
or just use WSL.
I was trying to, and WSL just isn't working on this computer.
You can't get it with
It's
sudo
not
app
quite
yet.
working, but
It's a video.
It's a
yeah.
what?
Yeah.
How can you get it with sudo app yet?
PC and you don't have sudo.
Look, why did it print this whole stuff?
I do, but WSL
Yeah.
isn't working on this machine.
Oh.
I don't think I've.
Yeah, that's because I was using Empire.
Yeah.
Hmm.
Just downloading it for.
The fire was crazy though. I never seen something like this.
No one
Yeah.
said what.
How did you do it?
That's just CACA Fire. It's like a demo. So if you have what is this, Ubuntu?
No, this is a Mac.
Is it Mac?
Yeah.
Brew?
I think you broke my terminal.
Type in reset.
He broke his terminal.
Oh, this says virus protected.
Oh, cool. I just learned something too. I'm going to make notes myself.
Yeah, reset will reset all the laptop settings.
Banner.
Yeah.
There's also a command called resize, which is sometimes useful because that'll tell you how big your window is. You don't have Excel. Unlike an Xterm, you would have resize.
Uh-huh.
Yes. Is you connected?
Hi. Yeah.
Is Nmap different than Netcat? What's the difference?
Nmap is a much more advanced utility that allows you to scan for open or closed ports. And Netcat is a program that establishes direct connection.
But are they by the same company?
Company?
Yeah.
They're both networking tools.
Okay, because what I'm seeing when I try to find it for Windows is Nmap.
No. Oh.
I'm out of the middle.
Why not use? What's wrong with WSL?
It's not working on this computer. It just won't launch.
Ah.
I need to probably.
What about Sigwin?
I don't know what that is.
CYG Win was before WSL. It was
No, don't use that anymore.
anymore, but it'll probably, I don't know, it'll do what you need it to do. Slow your computer down. I still have Sigwin on my computer. 7 years old.
Looks like from Windows it comes a part of the package with an Nmap. Vincent. So if you install Nmap, you'll also get an NCAT.
What's Nmap? Another build.
Nmap is a port scanner. It basically can scan ranges of IP address of different machines on your network and identify if there are ports open or closed.
Yeah.
This is like sort of the bread and butter of any security exploit vulnerability, reconnaissance, because that's the first thing you want to know, like what computers are on the network, what ports do they have open, because you can extract a lot of intelligence from that.
Have you given a class or lecture about that ever here?
No.
Can you?
Seva can.
Can you both?
Oh, and
Hack team.
But so, I think it was a lot of
I
fun.
would really love that. Like,
But I want to transfer it to Seva because Seva has a few things, cool things to show, and we can even do a little bit of a practice with the real switch, and we maybe connect to a network later, like make our own local network, connect, and play around with the similar tools.
So it was hacked into